Dear students, in this video lecture we are going to learn about ceramic materials. Most of the ceramics are compounds of metallic and non-metallic elements. The crystal structure of ceramics is more complex because at least two elements are involved in making a ceramic compound. So generally ceramic materials, what is the importance of ceramic materials? The ceramic material possesses very high mechanical property, very good thermal behavior property, and it possesses a very wide range of electrical property, etc. And because of its variety of properties, it is used in many industries, electrical industries, electronic industries, and in confectionery industries. In many industries it can have very good applications. So the ceramic materials can be classified based on three different categories mainly. The first among is, it can be classified based on how it occurs. Either it is naturally occurring ceramic material or manufactured ceramic materials. So the natural ceramics, the one of the very important now, one of the main natural ceramic material is silica or silicates and clay minerals. These two are the naturally occurring ceramic material and most frequently used naturally occurring ceramic material. And the remaining are manufactured ceramics like silicon carbide, aluminum trioxide, silicon nitride, and many varieties of oxides, carbides, borates, and more complex ceramics is also possible. Some of the naturally occurring ceramics are also manufactured, which results in their enhanced properties. In that sense, for example, silicon dioxide, it is available in nature, but still, if you want a improved property, even we can synthesize this naturally occurring silicon dioxide can be resynthesized by we can manufacture it to improve its property. When compared to naturally occurring naturally occurring ceramics, the manufactured one will have some extraordinary property comparatively. So for example, here it is given as magnesia. Magnesia can be obtained naturally as well as it can be synthesized. The natural ceramics are also called as traditional ceramics, while manufactured one will also usually called as high-tech ceramics or fine ceramics. The second classification, can be classified based on the functional classification, based on industrial application. The ceramics can be classified based on the industrial applications, in which industry it is used. For example, it is the first class is abrasives. So alumina and carborundum is used, and pure oxide ceramics like magnesium oxide, silicon dioxide, zirconia, etc. Fire clay products, it is used to make bricks, tiles, porcelain. So these are all some of the fire clay products. So inorganic glasses, so window glass, lead glass, etc. Cementing material, so Portland cement, lime, these are all some of the ceramics that can be used. Rocks, granites, sandstones, minerals, quartz, calcite, refractories, silica bricks, magnesia, some of the examples. And this classification is mainly based on the industrial applications. So for example, in sanitary wares can be made up of this porcelain material, tiles, etc. like that. So few materials can be used in few industries. Not any material can be used. Based on this industrial application, this classification is made. Then structural classification, so crystalline and non-crystalline. Mainly it based on structure, either it can be a crystalline ceramics or non-crystalline ceramics. So single phase crystalline ceramics like magnesia, alumina, or crystalline ceramics. And non-crystalline ceramics like glass uh, are non-crystalline ceramics. And certain ceramics have different a crystalline phase held in a uh, amorphous phase. For example, glass bonded. So in glass bonded, the matrix is sorry the matrix is glass, but the reinforced can be a crystalline phase. For example, alumina can be reinforced in a glass matrix, or some other apart from alumina, even some fibers can be reinforced. So here the inorganic fibers can be of crystalline nature, which can be incorporated in glass matrix. So that is a glass bonded ceramics. And cement, either the cement is crystalline or non-crystalline, crystalline and non-crystalline phases. Either the phases can be a purely crystalline phase, or as I told earlier, it can have both the crystalline phase as well as the non-crystalline phase. So based on this, we can classify ceramic materials. So these are the three different classification through which the ceramics material can be classified. Seeing the properties of ceramic material, first we talk about the mechanical properties. So the compressive strength is several times more than the tensile strength. The tensile strength in ceramics are theoretically high but practically low due to stress concentration at pores, grain corner, or due to micro crack. So when you talk about the mechanical properties, the compressive strength is several times more than tensile strength in that sense. So when we apply the force in all the direction, then tensile strength is depend upon the tangential force, and the compressive strength depends upon the force applied in all the possible directions. So when compared to the tensile strength, the compressive strength is very much larger, and the tensile strength in ceramics is practically it is very high. Sorry, theoretically it is very high, but practically it is low due to the pores. So it depends upon the pores, grain corner, or micro cracks. So if effectively we can synthesize a material without pores or without any micro cracks, then we can have a very good tensile strength, because as I told, the tensile strength depends upon the tangential force applied to the material. If there is any micro cracks present on the surface, that can lead to very poor tensile strength. So the tensile strength can be improved by avoiding such pores or micro cracks formed in a material, ceramic material. High shear strength and low fracture strength leads to non-ductile or brittle nature. So generally, the ceramic materials has a brittle nature, and mostly it is non-ductile, and that is one of the main advantage of ceramic materials. That's why the ceramic materials can be used in um, many places. For example, it can be used as laying tiles, and it can be used in many different applications. The ceramic materials possess high modulus of elasticity, ranges from 7 into 10 power 10 to 42 into 10 power 10 Newton per meter. And in that sense, not one material can have these two values. It is in that sense, there are certain ceramic material which possess a value of 7 into 10 power 10, and there are certain other material which can possess a value of 42 into 10 power 10. So like that, it can have a very high range of Young's modulus value. High, so that means high range of modulus of elasticity value. At high temperature, rigidity is high. In that sense, the rigidity modulus is high at higher temperature. So due to restricted slip, most of the materials does not permit plastic deformation. So the slip is it's nothing but one layer. How one layer of atoms slide over the other, it is more restricted. So in that sense, it is hard nature. There is no plastic deformation can occur in this material. And then optical properties, when you talk about the optical properties, ceramic glasses are highly transparent and capable of filtering harmful UV radiation. So the very good transparency when compared to any other material, maximum transparency is obtained in ceramic glasses. Even if you compare with PMMA, polymethyl methacrylate, where it transmits only 92%, but here the ceramic glasses can transmit about 98 to 99% of light falling on it, and it can also capable of filtering the harmful UV radiations in most of the wavelength region. Whereas if you consider the PMMA material, it can filter the UV radiation only in the wavelength range of 300 nanometer. If the but this material can restrict a wide range of wavelength ranges. Certain special glasses can be used as selective transmission or absorption of particular wavelength. So in that sense, optical filters can be made up of ceramic material, where it can restrict certain wavelength or it can allow certain wavelength. That is possible with ceramic materials. So talking about its electrical properties, it possesses a wide range of electrical properties. It can act as insulators, conductors, semiconductors, and dielectric materials. And its electrical properties greatly depend upon the volume resistivity, dielectric strength, dielectric constant, and dissipation factor. But we can have a very wide range of electrical behavior. So chemical properties, it is almost inert to all the chemicals except hydrofluoric acid and to some extent hard caustic solution. Apart from that, it is highly resistant to all chemicals. They are not affected by any organic solvents, and oxide ceramics are completely resistant to oxidation even at higher temperatures. And zirconia, magnesia, alumina, graphite are some of the materials which can be used to make crucibles and furnace linings, because certain materials can initiate chemical reaction at higher temperatures, but these ceramic materials possess very good resistance to chemicals even at high temperatures, so it can be used to make crucibles. And its thermal properties, so generally the thermal capacity is very, it possesses a very low thermal capacity value. For example, fine clay bricks, the thermal capacity value is 0.25 and 0.297 at 100,000 degrees Celsius and 1400 degrees Celsius respectively. And carbon bricks possess 0.812 at 200 degrees Celsius and zero point 0.4 at 1000 degrees Celsius. Like that, the thermal capacity, yeah, it depends on the thermal conductivity value. So generally, these material possess very low thermal conductivity value, since the thermal capacity can also be very poor, and they do not have the thermal conductivity is very poor because they do not have any free electrons for the conduction of heat energy. The impurity content, porosity, and temperature decrease the thermal conductivity. So the presence of impurity phases porosity can alter its thermal conductivity value to a certain extent. In order to have maximum thermal conductivity, it is imperative to have maximum density, which most of the ceramic materials do not possess, because the ceramic materials, since it possesses a very low thermal conductivity value, it can be used in making furnace. The inner surface of the furnace are made up of ceramic materials, and even certain crucibles are made up of ceramic materials. So thermal shock resistance, another very important property of thermal property is thermal shock resistance. The ability of this material, it possesses a very good thermal shock resistance, and it can withstand the property even if there is a sudden change in temperature. So lithium compounds are used in ceramic compounds to reduce thermal expansion and to provide excellent thermal shock resistance. So generally, even that is the reason why we use certain crucibles are made up of ceramic materials, and inner surface of a furnace can be made up of ceramic materials, because in a furnace we heat it to a very high temperature, and we decrease the temperature, and it should be stable at both the temperatures. It is possible only with ceramic materials. Apart from that, it possesses very excellent nuclear properties. So as ceramics are refractory, chemically resistant, and it is different, its different composition offer a wide range of neutron capture and scattering characteristics, so which find a potential application in nuclear power plants. So finding nuclear applications such as fuel elements, moderators, controls, and shielding. Okay, a very important aspect is shielding. So mostly this nuclear shielding cannot be done with any material, but ceramic materials plays a vital role in shielding the because the harmful radiations get emitted from a nuclear power plant that can be shielded by ceramic materials. The advantage of ceramic materials are ceramics are hard, strong, dense. They have high resistance to chemicals. They have a high compression strength when compared to the tensile strength. They offer excellent dielectric properties, very good thermal insulating behavior, and possess very good thermal shock resistance, and it is cheaply available, etc. And the applications, as the properties has a very wide range of properties, the application is also very wide. It can be used as tiles, sanitary wares. It can be used in chemical industry to store chemicals. It can be used as pyrometer and radiant heaters, and can be used in as refractories in for industrial furnace, and it can be used in as a piezoelectric crystal to produce ultrasound, or it can be used as semiconductor industries. And as since it possesses nuclear application, it can be used as fuels, this UO2 UC, or ceramics, which is employed for uh, nuclear fuels, and it can be used as cutting tools. And the it trolls is a ceramic material, a new kind of ceramic material which has it's used as a window glass and can resist very high temperature. If the internal has to be cool, then we should have a very good material which can resist the high temperature. So international combustion engines can be made up of this ceramic material, electronic package, cutting tools, energy conversion, etc. So with this we come to the conclusion. The next topic we see that in next lecture.